Hello student, welcome and very good morning to you. Today I will be discussing the solution of Irodov numerical 29, 30, 31 and 32. These solutions will be extremely helpful for the preparation of JEE Advanced. I have already uploaded the easy solutions of numerical 1 to 28. These solutions also be helpful for you to get the clear concept in kinematics and relative motion. Please like and share the videos and write a comment on it because this comment will be extremely helpful to make the next video for you. Now question number 29. A body is thrown from the surface of the earth at an angle alpha to the horizontal with initial velocity v0, assuming there is no air drag. Find. Look at this first of all figure. This is the earth surface and this is the x-axis and this is the y-axis. Okay. A particle is projected with velocity v0 at an angle alpha with the horizontal. So horizontal component of velocity vx, this is the v0 cos theta, no problem. And vertical component of velocity, this is the v0 sin theta, no problem. This is the vertical component of velocity vy. The trajectory of the particle due to these two velocity and acceleration towards the downward direction like this. Suppose this is the initial point O and final point A. The maximum height reached H. This is the H. And horizontal range R. This equal to OA. Now we have to calculate the time of motion, that is capital T, that is time required by the particle to reach from point O to A. Okay. Now look at this. Maximum height, look at this. We have to calculate the maximum height H, this height. And horizontal range R equal to OA. And at what value of the angle alpha they will have their equal to each other. That is, we have to calculate alpha where r equal to a. Okay. Now suppose p x comma y be the position of the particle. So here look at this, x equals to, this is the v naught cos alpha into t, and y equal to, this is the v naught sin alpha into t minus half g t square. And vertical component of velocity, look at this is the vy square equal to, this is the v naught square sin square alpha minus 2gy. Okay. And with respect to time, the vertical component of velocity vy equal to v naught sin alpha minus gt. No problem. Now we have to calculate total time of motion. Look at this, when t equal to capital T, y equal to 0, because the particle again reaches from O to A, that is vertical height assumed by the particle is equal to 0. Now putting this condition, when t equal to capital T, y equal to 0. So look at this here, 0 equal to, this is the v naught sin alpha into t minus half g t square. Therefore, look at this is the half g t square, this equal to v naught sin alpha into t. Therefore, t equal to 2 v naught sin alpha divided by g is the total time of flight. Okay, look at this. At the top point of the journey, the vertical component of velocity Vy is equal to 0. Okay, no problem. So look at this. When Vy equal to 0, the particle reaches the maximum height. Using this formula, we can get, look at this, when Vy equal to 0, y equal to maximum height. Okay, so look at this 0 square equal to, this is the V naught square sine square alpha minus 2gh. So maximum height h, this equals to, this is the V naught square sine square alpha divided by 2c. Okay, no problem. Now we have to calculate the horizontal range. Look at this horizontal range, x equal to r equals to, this is the V naught cos alpha into total time of flight. Now this becomes V naught cos alpha and total time of flight, this is the 2u, this is the 2 V naught sin alpha whole divided by g. Therefore, r equal to, look at this, r equal to, this is the V naught square sine, this is the 2 alpha by g. Okay, understood. Now next, at what angle of inclination alpha the horizontal range r and maximum height h be equal. Okay, therefore here r equal to h. Now what is r? R is the V naught square, this is the sine, this is the 2 alpha by g. And what is the h? H is the V naught square, this is the sine square alpha divided by, this is the 2g. Now look at this, this is the g, g cancel out, V naught square cancel out. Therefore, look at this is the 2 sine 2 alpha. Now sine 2 alpha means 2 sine alpha cos alpha equals to, this is the sine square alpha. No problem. Therefore, from this equation, we can easily calculate. Look at this from here. This is the, look at, from this equation, we can easily calculate sine alpha and thus cancel out. So look at this is the 4 cos alpha. This equal to, look at from here, this is the 4 cos alpha, this equal to sine alpha. Therefore, tan alpha equal to 4. Therefore, alpha equal to tan inverse 4. The R and H are equal. That is at the angle of, that is at the angle of projection tan inverse 4. The horizontal component R and maximum height H are equal. Okay. Now, question number C. The equation of trajectory yx, where y and x are the displacement body along the vertical and horizontal direction. Okay. Now, look at this. Suppose this is the ground and this is the x-axis. This is the y-axis. Okay. This is the alpha is the angle of projection. V naught is the initial velocity. And look at this. This is the trajectory. Look at this horizontal component, this is the V naught cos alpha, and vertical component, this is the V naught sin alpha. Okay. Now you know, suppose the particle reaches Px comma y in time t. So look at this, the vertical height Sn, this is the y, and horizontal distance travel, this is the x. So look at this here, x equals to, this is the V naught cos alpha into t. Therefore, here t equal to, this is the x by V naught cos alpha. No problem. Now, what is y? Y equal to, look at this, this is the V naught sin alpha into t. Acceleration due to gravity is directly downward direction. So, this is the minus half g t square. Now, put the value of t in this. Now put the value of t in this equation. So you can get y equal to, this is the V naught sin alpha and t equal to, this is the x by V naught cos alpha minus half g t square. T square is the x square divided by V naught square cos square alpha. Therefore, y equal to, this is the x tan alpha minus this is the g x square by v naught square cos square alpha is the trajectory of the particle. Look at this. This is the equation of parabola. So trajectory of the equation is parabolic. Okay. Now fourth question. The curvature radii of the trajectory at the initial point and its peak point. Now look at this. Look at this. This is the x-axis. This is the y-axis. This is the equation. This is the equation of trajectory. Now we have to calculate the radius of curvature at the initial point. Look at this. At the initial point, velocity is the v naught. Now, acceleration due to gravity g is the downward direction. So, component of acceleration along this direction. Look at this. Component of acceleration along this direction. Look at this. This is the alpha. This is the 90 minus alpha. So, this is also alpha. So, component of acceleration. This is the g cos alpha. Okay. Therefore, look at this, the normal acceleration. Look at this, the normal acceleration. This is the V naught square by radius of curvature. This equal to g cos alpha. Therefore, radius of curvature are equal to this is the V naught square by g cos alpha. Okay. Now we have to calculate the radius of curvature at the top point. Now look at this at the top point, the velocity of the particle. This is the V naught cos alpha. Acceleration due to gravity g, particularly downward direction. This angle 90 degree. If r dash be the radius of curvature, so look at this. This is the so look at this. This is the V naught. So look at this. This is the V naught cos alpha whole square divided by r dash equal to z. Therefore, r dash equals to this is the V naught square cos square alpha divided by g is the radius of curvature at the top point. Okay, no problem. Now, question number 30. Using the condition of the foregoing problem, draw the approximate time dependence of the moduli of the normal and tangential acceleration factor as well as the projection of the total acceleration W on the velocity vector direction. Now look at this. This is the trajectory of the particle. Look at this. This is the x-axis. This is the y-axis. Okay. V naught is the velocity of projection, and alpha is the angle of projection. And this is the trajectory. And this is the trajectory. Now we have to calculate the normal acceleration omega n and tangential acceleration. This is the omega t. Look at this here. Component of velocity along this direction. This is the v naught cos alpha. And in vertical direction at any time velocity v equal to this is the vy equal to this is the v naught sin alpha minus gt. So resulting velocity v equal to this is the vx square plus vy square. So look at this. This is the v naught cos alpha whole square plus this is the v naught sin alpha minus gt whole square. No problem. Now this is under root. Okay. So V square equal. Look at this. This is the V naught square cos square alpha plus V naught square sin square alpha minus 2 V naught GT sin alpha plus this is the G square T square. No problem. Now from this equation, look at this. From this part, you can easily write V naught square. So look at this here V naught square minus 2 V naught G T sin alpha plus this is the G square T square. No problem. Now differentiating this equation with respect to T. So look at this. This is the d dt of V square. This equal to this is the 0 minus 2 V naught G sin alpha plus this is the g square into 2t. So look at this here 2v, this is the dv by dt, this equal to, look at this is the g square t minus 2 v naught g sin alpha. Okay, no, 2 cancel out. This is the 2, this and this cancel out. So tangential acceleration dv by dt, this is the wt, this equals to, this is the g square t. Now v naught g sin alpha, this can be written as vy, initial velocity v naught y, initial velocity vy into g divided by v. Okay, understood? Now look at this here dv by dt, this equal to, this is the negative sign of g, and here v naught sin alpha minus gt. Look at this is the vertical component of velocity, and this divided by v. So look at this minus g into vy by v is the tangential acceleration of the particle. Now normal acceleration equal to, look at this is the g square, and tangential acceleration this equal to, this is the g square vy square by v square. Now look at this is the g square, so this is g square into v square minus vy square by v square. Look at this v square minus vy square, this is the vx square, so g square vx square by v square. Therefore normal acceleration, this is the g vx by v. Okay, therefore tangential acceleration of the particle, this is the negative sign of g vy by v, and normal acceleration, this is the g vx by v. Okay, understood? Now question number 31. A ball starts falling with zero initial velocity on a smooth inclined plane, forming an angle alpha with the horizontal. Having fallen the distance h, the ball rebounds elastically off the inclined plane. At what distance from the impact the point will the ball rebounds from the second time? Now look at this. This is the inclined plane. Angle of inclination, this is the alpha. Okay, this is the alpha. This is the height h from which the ball falls on the inclined plane. Look at this. This is the normal to the incline. Look at this angle is alpha, this is the 90 minus alpha. So look at this is the 90 minus alpha, so this is the alpha. Therefore angle of inclination of the inclined plane of the particle is alpha. So after reflection, the velocity of the particle directed along this direction. Suppose this velocity is the v, and v equals to, as it falls from the height h, this is the 2gh. Okay, now the component of this velocity in the normal direction, look at this is the v naught cos alpha, and along this direction this is the v naught sin alpha, because this angle is alpha. Okay, now component of acceleration due to gravity along this direction, this is the g sin alpha, and acceleration normal to the inclined plane, look at this normal to the inclined plane, this is the g cos alpha. So total time of flight, look at this t equal to, this is the 2 v naught cos alpha divided by, this is the g cos alpha. Therefore total time of flight, this is the 2 v naught by g. Suppose the particle hits again on the inclined plane at this point. Now we have to calculate this distance. This is the A and this is the O. So we have to calculate OA. Now what is OA? Look at this. Along the OA, the initial velocity, this is the V naught sin alpha. Acceleration, this is the G sin alpha. and time of motion is the capital T. So look at this. This is the V naught sine alpha into capital T plus this is the half into A. A is the G sine alpha into T square. Now look at this T into here you get this is the V naught sine alpha plus half G sine alpha into T. What is T? T is the 2 V naught by G. Okay, no problem. Now G and G cancel out. 2, 2 cancel out. So look at this. You can get T into this is the 2 V naught sine alpha. Now what is T? T is the 2 V naught by G into this is the 2 V naught sine alpha. Okay. So look at this here. This is the 4 V naught square by G into sine alpha. Now V naught square equals to this is the 2GH. So 4 into 2GH into sine alpha divided by G. Okay. So look at this. This is the 8H sine alpha. Okay. Understood. So distance covered along the inclined plane OA, this equal to this is the 8H sine alpha. Okay. Now question number 32. A cannon and a target are 5.10 kilometer apart and located at the same level. How soon will the shell launched with the initial velocity 450 meter per second to reach the target in the absence of air drag? Look at this. Suppose this is the x-axis horizontal surface and this is the y-axis vertical surface. Okay. Now the cannon is projected along this direction and the trajectory of the cannon is this point and this is the position of the target and this is the initial position of the cannon. Okay. Look at this. This distance is the 5100 meter. Okay. Look at this. If V naught be the velocity of projection, V naught equal to this is the 240 meter per second. So component of velocity along the horizontal direction, this is the 240, this is the cos alpha, this is the angle of projection, and this is the 240 sin alpha. No problem. Now, T be the time at which cannon hit the target. So look at this. This is the 2 into this is the 240, this is the sine alpha whole divided by G. G is the 10. So look at this. From here, sine alpha is equal to this is the 48 by T. Okay. This is equation number 1. Now look at this here. Look at this. This is the horizontal distance 5100. This equal to the horizontal component of velocity. This is the 240 cos alpha into T. Okay. So look at this here. This is the cos alpha equal to this is the 5100 by this is the 240 T. Look at this. This 0 and this 0 cancel out. And look at this. This is the 6 4 jar 24 and look at this 6 170 and this is the 85. Okay. So you can get cos alpha equals to 85 by 40. Now look at this. We know sine square alpha plus cos square alpha equal to 1. So look at this. This is the 48 by t whole square plus this is the 85 by 40 whole square. Okay. This equal to 1. Look at this. From this equation, you can easily calculate the quadratic equation of t square. From here, you can get applying Siddhartha formula t square equal to, so you can get easily t equal to 25 seconds. Okay, understood? Many thanks for watching this video. This video will be extremely helpful to build up your concept in kinematics and relative motion. Okay, thank you.